At this point, I want to hand across to Carl and Lior from New York University. I love Carl's title there, Chief Wizard. That's fantastic. That's absolutely brilliant. I'd love that on a business card. And also from Red Hat, Shane Baker, who's a technical account manager for New York University. They're now going to come up here and tell their story around their migration onto OpenShift Virtualization and their use of OpenShift Virt and also containers going forward as well. So at this point, I will hand across to Shane, Lior, and Carl.
All right, so who are we? We are NYU Research Technology Service. We support the research community team at researchers at New York University. We have a fun, interesting life in the sense that we have very complicated problems with researchers coming in with different requirements, workloads, and the beauty of our life is we have a lot of autonomy in the things that we get to do. We can pivot quickly if some new open source features are out, we can get right to it. A little bit about NYU. So yes, we are a university, but we are also a research enterprise. Last year, we had $1.52 billion in research expenditures. Lots of numbers, things, but we're not here to talk about like those aspects. Yes, we've accelerated research growth year over year. We are R1 Institute, so lots of stuff. We are the #1 NSF-funded research institution in New York City. NYU faculty rank in the top 1% of the world's most cited researchers. Researchers? Yes, correct. Okay, and now for the good stuff.
All right, good morning, everybody. So we kind of started our virtualization journey because we were hosting a large HPC facility. Most of our admin nodes were on bare metal at the time. We needed some ways to stop wasting so much physical resource to cut some costs, and we needed a way to start being able to have some development environments to be able to, actually update some of these services in a more timely cadence. So we settled on RHV for that. That was partially because I had done a lot of work with Overt in the past. And it definitely met that need. The small subset of VMs that were once just running on like a KVM hypervisor, we were actually able to make that a little bit more HA. Our VMs could fail over, it was all good. But as we kind of started on the HPC side to automate more of our infrastructure, we started finding a few pain points with virtualization. Deploying new VMs was a little bit clunky. Admins tended to be more comfortable using the RHV GUI to do that. So there's no consistency on kind of resource allocations for any of that. It took time. An admin had to go click through, do all the little things to make stuff happen. And then the kind of most annoying thing in my mind was this configuration drift. Once these VMs kind of got up, they, had different iterations of RHEL. They had different custom configurations, and then there's this huge configuration drift that happened over the life cycle of those VMs. And then on top of that, we started getting requests from the research community like, oh, we need to host 1, 10, 5 VMs here. And it's like, well, we don't have a full staff of people to be able to do that. So, next slide.
So what did we do, Carl?
The solution. We had recently started deploying OpenShift. KubeVirt was kind of a recent addition to that. So we found some things right off the bat that we really, really liked. One of those was this ability to kind of support a sense of multi-tenancy, just built-in parts of OpenShift that people have been talking about so far today. A researcher could have a VM in a project. That project can't talk to any of the VMs in another area. So that was great. Also, Overt was a good project, but it wasn't kind of developing at the scale to, new features weren't coming down the pipe. We also really enjoyed some of the better administrative capabilities. We had, again, it's just Kubernetes underneath. So like, if we have a cloud team who's comfortable like deploying things in OpenShift, it's just a YAML VMI. It's really easy to be able to spin that up. The baked-in GUI for the VM dashboard makes it super easy for someone who isn't familiar with the YAML side. You can click through, do some of the little templates. Your VM is up. You can see it immediately. The OpenShift virtualization teams, they keep adding new functionality and new features all the time. So that's something that we've really, really enjoyed. And then we can support containerized NPM workflows simultaneously. They can be in the same projects. They can cross projects. It made it really flexible for what we could do with our researchers. One of the things that we really like about OpenShift virtualization, the KubeVirt community, is just this sense that they're not building like a little silo in Kubernetes. Like everything that they do, feeds back into the native Kubernetes APIs. If they're building out some new functionality, it's not just for VMs. It tends to be stuff that benefits the community overall.
And that goes to the KubeVirt razor that was mentioned earlier, right? Is that if it's beneficial for VMs, it's beneficial for pods and vice versa. So by a show of hands, who here has used RHV? I got a few hands. So some of these problems probably seem kind of familiar to you as far as the modularity and all of that. How many people here currently use OpenShift virtualization? All right, we've got some folks. Okay, how many people have OpenShift, the operator installed, but don't yet use OpenShift virtualization? Okay, so we've got some people who are working on it.
Cool. I recommend trying it out.
Here's the plug right there.
Was that the next one? Okay, so this is one of our racks. This is one of the 2 racks for our OpenShift cluster. We have 3 control planes, 8 ODF nodes. Did we write in here? Okay, so we run OpenShift Platform Plus. And so this rack you're seeing is a direct liquid cooled rack. So 97% of the heat is dissipated through liquid cooling. So it is sustainable. We have sustainability requirements. In that rack of blades, there are GPU nodes, there are large memory nodes. Yes, if we're going to do something, we're going to do it big. We have dual 100 gig NICs, fast NVMe backend storage, and our journey.
We also have some other storage that's not on there, provided by a third-party vendor. But that's the basic bit of the hardware there. So how did we get to where we are? So where we really started with OpenShift virtualization was we wanted to take it kind of as like a fresh page in this journey. We had on the RHV side a lot of legacy VMs, some stuff running like RHEL 7, RHEL 8. So rather than just porting directly those VMs onto the new platform, we kind of took it as an opportunity to clean house, standardize some of those deployments, like to get rid of some of those problems I'd mentioned before, and really kind of make sure we were deploying like the latest kind of releases of the OS as we were going forward.
And so some of our growing pains in the current release, which actually the last speaker talked about, is live adding resources, CPU and RAM and chain. So
we're going to be talking about that later throughout Kubecon. So,
okay.
yeah. So we don't want to steal anybody's thunder with all the new functionality that'll be coming out.
And that's just to show that, yes, it is continuously evolving, and some of the pain points get resolved in new releases.
And then kind of the next thing that we really wanted to start with this was, we wanted to build upon some of the stuff that we've done. So in addition to like an HPC facility, which I mentioned we run, we also have a side of the house that manages public cloud infrastructure. They'd put a lot of work in over the years in building out a whole lot of Terraform code. They're very comfortable with that. So we wanted, and on the container side, like I'd been deploying a lot of things with Argo. On the HPC side, we had basically fully automated most of the day-to-day stuff for running that environment with Ansible automation platform. And so we wanted to take kind of all of these things and bring them together. To glue in the Terraform, I wrote a little Go app that basically heavily utilizes templates to like pre-populate a crazy amount of Terraform code off of a nice kind of like JSON level object of like a user gets a project, user requires these resources, numbers of VM, different storage stuff, and then like Terraform just goes crazy.
I think the title of Wizard actually fits him.
That's what I was thinking.
So that was like a night and day shift from the RHV side. Eventually we'll have a self-service portal where a user can just, request their VM, and on the back end it'll go, the Terraform will be applied back into the cluster and all this stuff will be spun up for them. But right now, rather than an admin having to go through and click through 100 different menus on the UI to, my VM needs to have a bridge device on this network, or, it needs, a MetalLB service to expose this outside of the OpenShift cluster, or it's just a totally internal, like OpenShift networking within the namespace it's working in. Like, all that the admin has to do right now is go and like fill out, like basically set a few key parameters, and then it's good to go. And then another thing that was very nice about OpenShift Virt is, the GUI is very beautiful. I mean, the metrics are all right there. One of the things that was kind of most annoying for the overt stuff was the console. If I wanted to be able to, if I needed to get onto the console for my VM, there was you kind of had to download a desktop app to maybe be able to connect to it. It worked really well on Windows, but most of our team was using Macs. It worked in some releases, not in others, but with OpenShift Virt, you just see the console there. Like, it works in your browser all the time. Same with the metrics tools. At one point, they baked in Grafana as kind of a side level on RHV. But now, like, all the monitoring stack is in all the places you're used to looking for it in OpenShift. The Virt CLI, super great if you're working with a terminal. And, like I mentioned before, it falls into that namespacing project segregation of OpenShift.
And you start small, automate first, and it doesn't require an army for this entire platform. Actually, it was a small team, this guy. And we got a few more people to chime in and help.
Yeah. And so one of the ways that we used that was the Cloud.net. When a VM starts up, it has a very basic execution flow to add in some configuration to enable it to execute an Ansible callback. So, then Ansible can come in and do whatever it needs to do to those VMs. So we've gotten to a pretty good spot. We've ported over like most of those early like HPC, our research technology services VMs that we require for our day-to-day stuff. We've got a few things left to do. We've got a few VMs left that we need to recreate. There's some things that I want to figure out with disk image pipelines, because while these Ansible callbacks are really good for kind of these, one-off style or sorts of machines where, like, I'm not trying to spin up 100 of this one type of instance, but with researchers coming on, like, we might have a bunch of users who need the exact same configuration, so that like additional 2 to 3 minutes or whatever that Ansible's going through and reconfiguring the VM. I kind of want to work on my disk image pipelines a little bit more to get just some pre-staged kind of golden images up for people. We're going to start hosting that in our Quay registry. I'd be very interested to play with kind of the service mesh integration, just because we do have some potential use cases where the traffic coming off of a VM isn't encrypted, so it'd be really nice to be able to like get that onto the mesh, secure that. Also, with it being on the mesh, we got all sorts of very cool metrics into the communication flows between stuff that just wasn't available for us in the older RHV style environment. And then I mentioned self-service we need. But, you know, not everything. Well, so that's the other thing. So while we weren't just directly moving VMs. By recreating them, we have the opportunity to kind of go back and reassess whether or not, like, does this VM need to be a VM? Is all that's on this VM like a MariaDB or a Postgres database? And if that's the case, like, that's just a lot more stuff to manage. We have to put security endpoints, agents, and stuff like that. We have to constantly update the thing. Maybe that workflow can just be containerized. Let's use one of the existing operators out there and put the database just as a container. But not everything can be containerized, and you know there is a legit use case for a lot of VMs in the modern world. So some of the ones that like we needed as VMs are listed on this screen. We've got Open On Demand, which is a very useful application for HPC workflows. XDMod, which is basically metrics on HPC workflows. Our internal like identity management policies, free IPA. We use that so people can log into everything. Satellite, you know, various other stuff. And okay, so one of the things that we're also interested in, like we had a lot of researchers who are just creating like, you know, shiny web UIs to do some like data science workflows. OpenShift has an OpenShift AI, which has all of this stuff prepackaged. I don't need to like make sure I've got the latest CUDA drivers. You know, I don't have to make sure like we're downloading whatever version of Torch. OpenShift AI just is this bespoke, beautiful little platform where researchers, once they can get their feet around the UI, they can just do their work.
And some of the, on the right column, these are some of the research applications for chemistry, GROMACS, Trinity for RNA and genetic sequencing, MATLAB, Nextflow biology pipeline. So a lot of interesting tools that we use in the big supercomputers, the HPC clusters, we were easily able to port.
So, you know, OpenShift, like I mentioned, is a huge ecosystem of stuff. So there are so many, like I mentioned, OpenShift AI, some of the operators for database, streams for Kafka is super cool. We've got some things that we're working on for that. The Knative serverless project. So like, you know, like not only do we not need a whole VM to house your database, you don't need a whole VM just to run like your Python application. That can be a serverless function or whatever. So there's some really cool stuff going on in OpenShift. We are running out of time.
Oh, perfect. Okay, we got to the end. So thank you very much for joining us on our journey for virtualization on OpenShift.
I'm sure you have a ton of questions. So please feel free to ask questions. We do have swag to give out to people.
We've got a couple of mics in the room.
Excellent.
If you'd like to step up to the mic, but yeah, fantastic opportunity to ask any questions. So feel free to jump in there.
Hi, I'm Beth Pariseau. I'm a reporter with TechTarget. Wondering if, as part of OpenShift AI, you're using VLLMs so far, and if so, what role do they play?
We're having some growing pains with VLLM at the moment. So NYU is that we're in like everyone else, we're in an early pilot phase for like how we're offering what we're offering. On the HPC side, we've got a ton of stuff that we've been doing for years. There are some very cool things in OpenShift AI for serving out larger models that I think will be really useful for us. But we also have some stuff in-house that we're trying to bridge. We had a lot of stuff that was in the public cloud, and we're trying to consolidate some of those things. We really have to manage like our data protection for that. The university is very concerned that like student data isn't going out to train the next version of OpenAI or whatever. But not yet. But maybe in a year or so we'll have some more on that.
Thanks.
Thank you.
Hi, Joe Segmiller from Brigham Young University. I've heard some reports that running VMs in OpenShift ends up giving you lower VM density on the same hardware than other hypervisors. I wonder if you've experienced anything like that.
So I think you're talking about other hypervisor technologies.
Yeah, the V word.
What's that?
The V word.
The V word. Other hypervisors with the V word that allow overcommit, right? Where you can pack as much as you want on there, assuming that you're not going to use all of the resources allocated to that host. That is something, and once again, not stealing the thunder, but that is something that's GA in 4.17. So OpenShift is working to bridge some of those gaps, right? It was mentioned in the earlier conversation during the keynote that the key to these type of functionality improvements are community involvement. So we listen to the community. They say, this is something that's really important to me, right? We can't allocate 8 gigabytes of memory to this VM that really is not going to ever use it, but it needs to be there in case it needs to use it, right? So those are the types of feedback that we take at Red Hat, and we help incorporate them, and we send it to the KubeVirt project. So we're working on it. So we hear what you're asking for. We're really eager to deliver.
Thank you.
And from what we've seen today, like I mentioned it a little bit with like trying to offload some of the things that don't need to be a VM for particularly that reason. And it's nice to know that this functionality is coming back into OpenShift, so it'll be less of an issue for those of us who are resource constrained and worried going forward.
Right.
Thank you.
Cool. Good question. Thank you.
Hey, just looking for clarity on the Terraform usage. We're using the KubeVirt provider with that?
So right now we're using Argo for the VMIs. The Terraform we're using for basically network policies, rollback, project creation, quota management. We may expand it, like I said. So we've kind of got like two sides of the house. Some people are like more comfortable with like the YAML GitOps sort of way, and others are like, can we just have it all in Terraform, please?
Hi, I'm Jennings. I'm from Boston Children's Hospital. I'm curious what this all looks like from the user side, or like just what researchers do. You mentioned you like run MATLAB and Nextflow for biology pipelines on OpenShift, was it? So yeah, how do you prepare your like research community to adopt to like the OpenShift way of things, or like creating their pipelines container first?
Documentation, documentation, documentation.
We also do a lot of tutorials once we kind of start rolling out some new functionality. We also benefit from, you're talking to some of the folks who tend to be back on kind of the more back end of the environment, but we also have a whole side of our team that really just, is interacting with researchers. So like, in some of the pre-alpha stage, the early steps of these, like it's a lot of hand holding, but direct one-on-one between our team and their team and those researchers. But people have picked it up quickly.
Yeah.
Sailesh Sankaran, Procter & Gamble. So I have a question about the performance benchmarking. So have you done like any sort of comparison with the old RHEV and the new OCP-based virtualization?
The storage backend is ridiculously faster on the OpenShift side. We dabbled with a few different storage providers when we were rolling out our HV several years ago, and some were abysmal, some were okay, but OpenShift has been just much more performant overall, both on the disk side, network side, and for CPU I/O stuff.
Did you try like Portworx type solution as well, or no?
We have not tried.
We have not tried that, and we're not going to get into who the vendor is, but it screams.
Hi, Daniel Rapp of Real Software. You mentioned, did you migrate stateful VMs to the new cluster? Like you mentioned the satellite, but you didn't migrate that, right?
No, so that when I said we took it as a clean page, we basically used it, we segmented off part of the team to automate the deployment of things like identity management, satellite. But when we got ready to switch over to the new environment, we basically just rebuilt from scratch.
Okay.
And there are some pros and cons. Satellite, we didn't want to migrate because we didn't want to do the leap upgrade because it was going from 7 to 8. And we just had like a ridiculous amount of like old packages left behind from, so we either would have had to clean up like a stupid number of content views or.
Yeah, I get that. Yeah. Okay. Thanks.
So you're asking about migration. Is there a specific question that you want addressed with migration?
Did you use the migration framework just from ref to?
So yeah, we have a number of customers who do use the migration toolkit for virtualization. It's very successful. It's a great tool. It's really evolved even in the last year.
Yeah.
It's the success rate of a migration from another hypervisor to OpenShift is actually quite astounding. It does a good job. So I would highly recommend it.
All right. Thank you very much.
Mm-hmm.
We've done that container migration toolkit that worked great. I
Yeah.
assume that the flow is
Yeah,
similar.
absolutely.
But
Yeah, there's the MTA, the toolkit for apps.
Yeah.
Are there other questions? Oh, there we go.
One more question. John, how you guys doing? When it comes to culture shifts, when you guys went from VMware or whatever your current VM architecture was to KubeVirt, did you have any resistance from the culture's perspective in that? And what does the culture curve look like when you went full OpenShift?
We didn't go from VMware, and one of the parts I said, we didn't get any pushback because we would be the people pushing back. We have full autonomy over it, and if it makes sense, we try it. If it works, it's great. If not, we pivot.
I mean, just to add on to that, I will say like the people who were responsible for managing a lot of the VMs from RHV were quite pleased with the changes when we switched to OpenShift Virt. I don't know if it was just the ease of like, you know, some of the things that I mentioned earlier, or if they were just ready for something new.